There is a wide range of possible consequences of structural failure. As we have been discussing, the loss of life is the most severe, and in the next few slides we are going to look at what level of risk to life is acceptable. But there will be many nuances to consider. For example, if we are able to identify an acceptable risk to life of one individual, how do we handle a structural failure that involves multiple fatalities? Then there would also be the question of the context of death. Was there a choice on the part of the individuals? By which I mean that was the person a member of the public, or was the person a professional in charge of, say, maintaining the building, or a construction worker, and so on. The other consequences obviously would be economic loss, and then what to include in that would be an important question, and obviously one uncomfortable question that has many implications, including moral and philosophical ones, is there a monetary value of human life, and if so, how to put that? And we also have been talking about environmental damage, and if we include that as a consequence, how to measure that. And this is all in the context of acceptable risk that we have been discussing in the hope of setting target reliabilities. So let's take a look at acceptable risks to life. Let's get some idea of individual fatality risks, some numbers, but before that, the levels of risk to an individual life from society's point of view could be at a level that is plainly unacceptable. It could be so high. There are other levels of risk to an individual's life which we may not be very happy about, but we grudgingly accept. It's kind of intermediate. We are ambivalent towards that. And then there are, on the other end of the spectrum, those risks that are unconditionally accepted by society. We really don't worry about those. So let's take a look at some activities or some hazards and what are the approximate individual life risk. So a rough estimate of death of an individual from all possible causes worldwide is about 8 in 1,000 per year. So that's a pretty stable estimate across countries. Now, if we look at death of a 30-year-old individual, otherwise healthy, from disease, that comes to about 10 to the minus 3 per year, and which would, without a doubt, be plainly unacceptable to society. So if we have to put an acceptable risk, we would need to go well below this. Then there are other activities which people undertake because of benefits that come from them, but the risks are definitely more than what we would like, which example being traffic-related deaths, about 1 in 10,000 per year, and that is what we see in the US, that's what we see in India, and we also see a very similar rate of gun deaths in the US. Now, obviously, these are not something that society is happy about. There are discussions about how to reduce these. So this level of 10 to the minus 4 per year per individual would be something that is on the borderline, or something that is in the gray area between clearly unacceptable and clearly acceptable. Now, what would be unconditionally accepted by society. Something like death from lightning strike, and that is of the order of 2 in a million per year in India, and almost one order less in the US. So that's roughly about 5 × 10⁻⁷ per year. Now, there could be various reasons that the death rate from lightning strikes in India is higher than in the US. It's possible there are more lightnings in India. It's possible that Indians spend more time outdoors on an average in the open, or it's also possible that more people are around in an area where lightning strikes in India than compared to the US. But in any case, this rate of 1 in a million or less would seem to be a number that a society would not be too worried about or would complain. So we could have this as a basis of what would be an absolutely unconditional acceptance. Now, whether this would be too low or not, that we can take a look at a little later. But there are other numbers that are interesting from offshore oil and gas workers in the UK. These are about data from 1960s and 70s. That's clearly very high, 2 × 10⁻³ per year. On the other extreme also, this is from the 70s or 80s, death from a very hazardous sport, which is roughly the same number. Obviously, these are different things. These are undertaken in some sense voluntarily, so there is not so much outrage at this level of fatality in these last two mentioned activities compared to what would be that you see in the death from disease that you see in the top. So these give an idea about the different ways that society reacts, and would also give an indication of what might be an engineering level of acceptable risk were we to set the target reliability for a structure. So in this slide, this is one set of reactions that society might have given all the different levels of individual risk to life, as reported by Keyes and Barton's paper. As we saw and as we decided, that 10⁻³ per year for an individual is clearly unacceptable. And we can see something like this right now in the middle of a pandemic worldwide, and clearly the levels of fatality that we are seeing are not acceptable, and that's why so many restrictions are in place, and there is so much concern going on. Now, the next level, 10⁻⁴ per year, is this is something people are concerned about. People are, if they can be encouraged, people are willing to take this up and reduce these risks. So this would be something that, as I said, on the borderline of acceptability. The next level is less than the other one, that people are still concerned about that, but not in a significant way, and people still warn about these, but it is not of great concern typically. So if we were to set some targets, we would keep this in mind. And then lastly, this rate of 10 to the minus 6 per year for an individual seems to be people are willing to accept and not worry about, and sometimes referred to as an act of God, and it can never happen to me, that sort of feeling. So with all of these, we now see some criteria actually set by some authorities around the world. So I have a survey of 3 countries, the HAC from the UK. So for a worker, the maximum acceptable risk is 10 to the power minus 3 per year for death. For the public, it is 10 to the minus 4. So that's on the higher end of the spectrum that we're talking about. And negligible risk is 1 in a million. That seems to come again and again. From the Netherlands, we see a different order of magnitude for existing situations which people are more comfortable with. It's 1 in 10 to the power 5, and for new situations, the tolerable risk is of the order of 1 in a million. So that kind of ties in with the negligible risk from the UK. In Australia, we see some of these numbers, and the acceptable rate for schools and hospitals are of the same order of lightning strike in the US. So they want it to be as low as that. For residences, they're of the order of 10 to minus 6, so very low, which is considered negligible in the UK. And for industrial and sporting and commercial activities, they are another order of magnitude higher in terms of acceptable risk. We see something from Patrick Cornell, just to summarize the general trend from around the world. She came up with certain recommendations that the risk to a worker should not be greater than 10 to the minus 3 or 10 to the minus 4 per year. For a member of the public, those would be 2 orders of magnitude less, 10 to the minus 5 to 10 to the minus 6 per year. And the de minimis that we have been talking, that's something that is of no legal concern, of just no consequence really. That is that could be as low as 10 to the minus 6 for a worker, and so that would be the ideal case. And for a member of the public, 10 to the minus 7 or even 10 to the minus 8 per year. So with these, we can try to see how buildings come in the picture, building failures or structural failures, and how we could then look at multiple deaths. So these are all for one individual. Now, if there are multiple fatalities possible, how we would handle that is also a very relevant question for building or other structural failures. Let us also look at this concept of fatal accident rates, which is a nice way of bringing in limited exposure. So what if an individual is exposed for a very limited amount of time, and so what would be the measure of acceptable death from such a limited exposure? So that is given by the FAR, and which is defined as the number of fatalities per 100 million hours of exposure, so which is the same as 1,000 people working full-time for 40 years. And that is given by this formula. So for any activity, if TH is, which is the exposure time in hours, if that is less than 2,500 hours per year. So that would be a nice way of putting all these different exposures and risks on the same metric. And for a worker, one could get back the annual fatality risk as the FAR divided by 40,000. Let's take a look at some of these numbers from two countries. One is India, which I have computed over the last few years. So it's interesting to see that rail travel is the safest when exposure is taken into account compared to all the other modes of travel. Walking is also a bit dangerous, and that's partly because a lot of these walking fatalities occur as traffic-related accidents. In Japan, in comparison, we see some different sorts of numbers, and we see that in terms of some of these numbers about air travel and about car travel and rail travel, the numbers between India and Japan are of the same range, especially in terms of rail travel. That number for buildings is actually very low, which seems to be a very good thing in terms of structural failures. But now we are going to look at what happens for buildings, and especially when multiple fatalities are involved.